What's up, folks? Mr. Reed here. I can do some study guide videos for you. Hopefully you can hear me alright. Hopefully you cannot hear my music, but we're going to go ahead and get started. So this is for Unit 1 on functions and graphs. Notice that this first part is no calculator, so that means no calculator, not even for basic math stuff. Do it in your head, you can do it. Anyways, we have three graphs given to us here. We would like to write the equation of each graph. That's all. We don't have to tell it domain or anything like that. So let's go ahead and get started with question 1, part A. So hopefully you are looking at this and you recognize this as the absolute value of x mother function. It's our v graph that looks like that. Normally, I'll draw a better one for you. Normally it is sitting with its vertex right on the origin like that, and it's going up to the right as a linear function with the slope of 1, and it's going up to the left as a linear function with the slope of -1. So that's what it should look like. That's not quite what it looks like here, however, because it is going down and it is not centered at the origin. So let's think about the transformations we have here. This point in the middle that we were talking about, it is not where it should be. It is 1 point to the right in the x direction. So I know that that's going to give me a -1 inside my absolute values. Remember, if we're talking about a horizontal translation, meaning a slide left or right, then we are subtracting 1 to move it to the right. We'll talk about why in a moment. But look at the other transformation we have here. It is also translated up 2. We accomplished that transformation by adding 2 on the outside of our function. And finally, the last transformation we have here is that this graph is flipped upside down. And to do that, we can throw a negative sign out front. Let's give this function a name. Let's call it f of x, just for fun, just because we can. And I just realized that I actually made a mistake. So what I want you to do at this time is pause the video and see if you can figure out what is missing from this function. So take a moment, pause. What mistake have I made? What do I not have in my equation that I should have based off of this graph? Alright, you either did it or you didn't. If you didn't, you had a little awkward silence there. Maybe I'll make it painfully long next time so you actually pause and think about it. But since we are talking about this absolute value of x function, you can think about the two halves of this v kind of as, part of a linear function, a line. So you can think of it as having a slope. And if you look, the slope of this graph, the rise over 1, is actually 2 y values for each x value. Hold on, my mom's at the door. Alright, good news everybody. My mom made chili, which is very exciting, and so she will bring me a bowl, and I will nibble on it while I do this. Hopefully I don't drop any chili onto my iPad. Anyways, we were talking about the slope of this function. So if you can acknowledge that we have a rise of 2 for each run of x, that's going to make us have a slope of +2. So I need to actually go up and add that in. So I'm going to erase my minus out front, and I'm going to put my 2, and I'm going to throw my minus in front of that. Now you should check yourself. You should plug in some points and see if you get the right values. I'm not going to do that, but you should do it. Haha, I tricked you. I actually did test a point. I checked and made sure that the origin actually went through our graph, or rather our graph went through the origin. But anyways, check this out. I think it's going to do a cool pan over to B for you right now. Let me know in class if it does. If you come up to me and tell me it did it, I'll know what you mean. Oh my goodness gracious, folks. I just had a bite of chili. It was delicious, although it's a little too hot. So I'm going to let it sit, and I'm going to show you that cool pan I was talking about. Ready? 3, 2, 1. You got to let me know if it did or not. Second function. Okay, let's recognize first off that the mother function here is our square root function that normally starts at the origin and curves off to the right like that. But ours is going to the left instead, which tells me it has a horizontal reflection going on. As your book calls it, a reflection in the y-axis. So let's call this little feller g of x, and g of x is indeed a square root function. But, however, since it has that horizontal reflection there, that flip, I need to throw a negative sign in front of my x value. Notice that I'm not putting it out front like that. If I did that, that would give me a vertical flip, not a horizontal one. And I want a horizontal flip because my graph is going off to the left. So I need that negative x, and then I need to do minus 2. Or wait, no, I can't do math. Not minus 2. How about this? How about minus 4, right? I think that's the thing I should do. Normally, don't you just put in the opposite of wherever you want it to go? So since I want it to go to positive 4 right there, I put in negative 4. Well, we can always test a point and make sure that happens. So I think in this case, it might be beneficial to do that. So let's test the x value of positive 4, because that should give us 0. So I'm going to plug in positive 4 in for my x right there, that little blank space where I didn't just write anything. So let's put positive 4, and I get negative 4 minus 4 is negative 8. Okay, so there's something wrong here. I made some sort of mistake. Let's try positive 4. So if I put positive 4 in there, then I get positive 4 minus 4 is 0. And the square root of 0 is 0. Huh. So, that's that weird thing that happens when you're dealing with a horizontal flip in addition to a horizontal translation. It messes things up. And here's why. Think about it this way. Normally, we put the opposite in there because if I had, for example, square root of x plus 2, and I wanted to know why that's moving it to the left. Well, think about this. That graph is going to look like this. Boom, going over like that. It moved it to minus 2, but why did it move it to negative 2? Well, if you think about that point right there, it's kind of like the starting point of our graph. It's also the lowest y value that we're ever going to have. From there on out, it's going to continue to go up and get bigger and bigger y values. So, if you think about the square root function, the square root function has its minimum value that it will ever hit when the argument, the stuff inside the square root, is 0. So if you set the inside of your square root equal to 0, x plus 2 equals 0, and you solve that equation, you get the y value that happens at that minimum value. So, well, that's not what I meant to say. You get the x value where your minimum y value happens, because that 0 is our minimum y value, and we want to find out where that x happens at. So, my bad, I misspoke, I do it. Anyways, we subtract 2 from both sides, and we get x equals negative 2. That's why it's backwards, because really behind the scenes you're solving that little mini equation. So if we look up at this function, when it's negative x plus 4, you have this equation, negative x plus 4 equals 0. We're asking ourselves, what x value will this function equal 0? Because that's the value of that point right there. So you subtract 4 from both sides, and you get negative x equals negative 4. And if negative x equals negative 4, then x equals positive 4. So, when in doubt, pull it out, set it equal to 0, check yourself. That should work. Anyways, that's long enough for that one. So, let's go ahead and move over to our final problem for number 1. Holy crap, Mr. Reed, this is a long video. I know it's a long video, but you know me. I like to talk about stuff. So, last one. Maybe you just saw it pan again. We need to recognize that this is either the cube root function or the cube function. Well, Mr. Reed, how do I know which one is which? Well, think about it. If you take the cube root of something, you're going to get smaller numbers. If you take the cube of something, those numbers are going to grow very, very quickly. So our two functions look like that, and that, if I could draw it properly going through the origin right there. But I can't. Anyways, which is which? Well, the cube root function grows so super fast. So that's our cube root. That's our cube, and that's our cube root function, because the cube function grows super fast. I don't know what I just said. I can't talk. But I can apparently make accidental marks on the screen. So let's get rid of that. Again, notice how this dot is right there. That's kind of marking that special point of our graph. You can kind of think of it as like the middle of your graph. I don't know if a graph really has a middle, but we can think of it like that. Anyways, that point is supposed to be there, but it's not. It's moved 2 over to the left. So I know that this is going to be a cube root function, like that, to the power of 1/3, same as a cube root. But x is moved to the right 2, and by to the right 2, I mean to the left 2. I said right because I was thinking about how we were just talking about it is opposite. So this needs to be x plus 2. That will move it to the left. And guess what? We're finally done with number 1. And by done with number 1, I really mean, do you know how tired Mr. Reed is right now? It is super late on Thursday night. I'm trying to get these done for you, and I'm exhausted. So I keep saying things inaccurately. So if I make a mistake in these videos, you let me know. If you're the first one to tell me, you don't have to wait till class. You can email me. If you're the first one to tell me of a mistake I made and didn't correct, I will give you 1 bonus point on the test. So there's a little incentive for you to pay attention. So pause it real quick. Check with yourself. Do you see the mistake I made? Because I see it. So pause. I just moved my hands through the air, pretending like I had pause. So look at the graph I drew up here. The normal cube root function goes like that. Our cube root function goes like that. That is a vertical reflection, which means I need to throw a negative sign out front. And again, I want to name this something, so let's call it h of x. Woo!